Now, very often you won't have any pure chemical, especially with some stronger acids. You'll only have a more concentrated solution. And so in order to make the solution you need, so let's say for instance you need a 2 molar solution, but you only have a 6 molar, you're going to have to do some diluting. You'll have a small amount of the 6 molar that you're going to add water to create a 2 molar. And this is the formula we use right here. I recommend writing it down and just having it close by because it's nice to have it with you. But basically, the molarity of the concentrated times the volume that you will use in your new solution of that concentrated will equal the molarity of the dilute times the volume of the new dilute solution. And this one can be hard to wrap your brain around, so we're going to go a little slowly here and try and get through it together. So on this one right here, I'm kind of annoyed that my slides have the answers laid out. But let's say that you need to make 1.5 liters of 2 molar solution, but you only have a 6 molar container of it. So what you do here is your molarity of the first one, let me change to blue. Your molarity of the first one times the whatever volume you're going to need, and you don't know what volume you need in this case, so you're just going to put a V there as a variable, will equal your new molarity times your new volume as well. Okay, so you're going to go ahead and solve. Now it doesn't matter which side is which. You can choose to have this be M1 and V1, or you can have this one be M1 and V1. It doesn't matter. What matters is that they stay on the same side. And once you solve for this variable V, you'll find that you're going to need 1/2 liter of the 6 molar solution right here. So you're going to measure out 1/2 liter or 500 mils of concentrated solution and add water until your final volume is what you needed in the first place, which was 1.5 liters. Okay? Again, can be hard to get your brain around, but after a couple practice problems, you should be able to do it pretty well. So let's look at our first practice problem here. How much of a 0.75 molar solution will you need to prepare 50 mils of a 0.275 molar solution? All right, so we have our molarity. Our first molarity is right here. I'm going to go ahead and write M1 right there. But it's also asking us here how much, and we don't know how much yet. We haven't solved it. So that's going to be V1. Then over here, we'll have our volume over here. This is V2. And then we've already got this molarity right here, so this is going to be M2. All right, so we've got everything, and remember, M1 V1 equals M2 V2. So M1 we have, it is 0.75 molar, but we don't have V1 yet, so that's going to go in parentheses, is equal to M2, which we have right here as 0.275 molar, times V2. I'm going to put V2 in parentheses here just because it's annoying. Now here's the thing you might have caught. This is in milliliters, and we need it to be in liters. So we're going to go ahead and just go 123.05 liters. Okay, and that's going to give us our answer in liters as well. It's always a good idea to just work in liters. It will make things easier on you in the long run. So now we're going to just do some algebra. So we're going to go ahead, I'm going to switch pen colors here to make it a little easier to look at. So the first thing I'm going to do here, I'm going to go ahead and get rid of the units just to make things easier on me. 0.75 times the volume of the first one is equal to 0.01375. Well, that's not terrible. Now I just have to divide both sides by 0.75, and I'll be left with V1 is equal to 0.0183, and 3 goes on to repeat. That's liters. Now, if you wanted to write that in milliliters to be a little bit more realistic for a lab setting, it would be 18.3 milliliters. I would accept either of those answers, but that's how many you're going to need. So basically, you're in the lab, you have 0.75 molar solution, but what you really need is 0.275 molar solution. So what you would do is you'd take 18.3 mils, you'd put it in a beaker, and you'd fill the beaker to the 50 mil line. And that would be your solution. That's how we calculate dilutions. On this problem right here, go ahead and give this a shot by yourself. Try it out. If you get stuck, come back and watch the video and see how I solve it. All right. So how much? That's going to be V1 of a 15 molar solution, that's a big molarity right there, so there's M1, would you need to prepare 775 milliliters, so that's going to be V2, of a 2.5 molar solution, that's M2 right there. All right, so we know that our variable is going to be that one there. Let's go ahead and write this out. M1, 15 molar, times V1, which we don't have quite yet, is equal to M2, 0.25 molar, times, I don't know why that's not picking up, times 0.775 liters of solution. Okay, we're going to go ahead and get going on that. 15 times V1 is equal to 0.19375. Both sides can be divided by 15, and V1 will be equal to 0.0129 liters, or 12.9 milliliters. So you would get this many of your really concentrated solution, put it in a container, and fill it up to this volume level right here, and that's how you're going to do that dilution. Last problem here, how much volume of a 5.75 molar solution, our first concentration, will you need to prepare this volume of this concentration? Okay, hopefully you're following pretty well at this point. M1 V1 equals M2 V2. So we're going to go ahead, M1 5.75 times V1 is going to be equal to M2 4.0 times V2 right here. It's going to be 0.080 liters. Okay, so we're going to go ahead and just condense our formula here. 5.75 V1 is equal to 0.32. Both sides can be divided by 5.75. Okay, and we're going to get an answer here. Volume of 1 is equal to 0.0556 liters, which is also equal to 55.6 milliliters. So if you needed a different concentration, you had 5.75 molar right here. This is what I've got in the stock room, but what I really need for my experiment is 4 molar. I would just need to get, and I only needed 80 mils of it, I would just put 55 mils in a beaker and fill it up to the 80 milliliter mark, and then I'd be good to go.